let's go over using synthetic division to perform division. I like to always identify 3 things before I start. That way I don't run into any issues. The first idea is to identify who your K is. Now, if you're looking at your notes, the K has to do with your binomial divisor. So it's coming from your divisor. I'll point to it over here. And the K is the idea of the constant term, except it's the opposite. So remember, the form of the divisor according to the definition is in the form of x minus k. So when you look at something like x plus 3, when you're trying to rewrite it in this form, x plus 3 is the same thing as saying x minus a negative 3. So what this tells us is that k is equal to negative 3. So that's the first idea. Now, what I always like to do as a shortcut is understand that if you are looking at your divisor, the k is always the opposite of what you see due to this idea. So if you see x plus 3, your k must be negative 3. So once we have the k, before we start doing any sort of synthetic division, we want to verify, are we in descending order? So I'll kind of go step by step with the terms. All the powers of x need to go highest power first and then decrease by 1 as we go. So we have 3x cubed, 2x, and then a constant. So we are in descending order. So a little note to ourselves, yes. And then the other thing we want to make sure is that when we are looking at our powers of x, we want to make sure that they're decreasing by 1 each time. So we go from x cubed to x to the power of 1. So it looks like we're missing something. And so we are missing an x squared term. And so what I'll do for myself, I'll just rewrite it so that I see it happening. I do have 3x cubed. And whenever you want to account for the missing term, you will add it as a plus 0x, whatever the missing term was supposed to be. I like to keep it as plus, but you're just using 0 as a placeholder. So you can say minus 0, but that kind of ends up being confusing. So go with what I told you. 3x cubed plus 0x squared. We have minus 2x and then plus 5. So now we have that dividend in descending order. All the missing terms are accounted for. Our divisor does not have any missing terms, so we're good to go there. So we are almost there. Now we can do our synthetic division we've all been waiting for. Whenever I run into synthetic division, the first thing I will do for myself is I will do put my k on the outside. I'll kind of give you the setup. And then I'll always write the coefficients of your polynomial. So what that means, my k would look like a negative 3. And then my coefficients of my polynomial in descending order, I'll have a 3, that missing term 0. And notice I'm spacing them out for myself. I have a negative 2, and I have a 5. So synthetic division gets rid of a lot of the variable issues. Next thing we do is we'll draw a bar underneath the coefficients that we have written. And we'll set ourselves up. So with synthetic division, the first thing you do is you're going to drop the first number below the bar. Rewrite it. Anything that you write below the bar is going to get multiplied by k, which is in our fact negative 3. Maybe I'll color code it just to make sure, according to what we had. So I'll take that green 3, multiply it by the k. 3 times negative 3 gives me negative 9. What I will now do is write that below the next coefficient, but above the bar. So it sounds a little confusing at first, but when you kind of go through it, you have a better idea. So that was 3 times negative 3 is negative 9. I write it underneath the next coefficient, but above the bar. And then what you do is you're going to add vertically. So 0 plus negative 9 gives us negative 9. You'll write that answer below the bar. Now we'll repeat. Negative 9 times negative 3. So negative 9 times negative 3 gives us a positive 27. We're going to write that underneath the next coefficient, but above the bar. Now we're going to add vertically, -2 plus 27. That should give us a 25. So we'll write that answer below. And then what we end up having, 25 times k, 25 times -3 is going to give us -75. So we'll write that right above the bar, but below the next coefficient, -75. So what I should have for myself, if I add vertically, I believe we're looking at -70. Yeah, so it happens. Now there's significance in the numbers that you have written beneath the bar. What I'll tell you is that this last number right here, we refer to as the remainder, just like you did when you had long division. And a little bit of the note I kind of left typed in, if you started out with a degree 3 polynomial and you divide it by a degree 1 polynomial, what's happening is you bump off the degree by 1. So just kind of keep in mind, I kind of do this with the first term anyways. I started off with 3x cubed. If you are dividing it by x, notice I'm just taking the leading term of each one. If you were to do a quick reduction, you notice that the x's reduce out a little bit, we would have 3x squared. Well, what's happening is that these are the leading coefficients of your resulting quotient. So finally, we can use this to give us 3x squared minus 9x. Notice I'm decreasing the exponent of the x by 1, plus 25. Excuse me, I did not write that negative sign. Bet you guys were all wondering, what's going on? Well, if you caught it, good stuff. But I always double check anyways. So I basically have my quotient. And what's going on here is I need to identify and address my remainder. Remember, we do that by writing the remainder over the divisor. And I'll be a little more specific. I use the sign of the remainder, and then I write the remainder over the divisor. In this case, the divisor was x plus 3. So now my final result, I have my quotient and my remainder. And I'll circle it. So that is how we use synthetic division. I encourage you to practice it with example 3. See how you do, and then go through the homework and make sure you're pretty fast at this. It looks a little complicated at first, but the more you practice, the more nicer it becomes, and then you'll find it a nice welcome addition instead of having to use long division.